Good afternoon and welcome to Math 65. So this is the first day of Math 65. We're reviewing stuff from Math 60 on graphing lines. Now, I will also say if this is material that is totally foreign to you, the best thing for you to do would be just to repeat Math 60 if it's been a while. So getting ready for graphing lines, let's talk about some review from Math 60, talking about the slope of a line. So use M, which is the first letter of a French word, mégateur, I think is what it is, that just talks about basically the steepness of the line. So we use the variable M for that. So does anybody remember anything about slope? What is slope? Okay, it's rise over run. And we also call that the change in x, the change in y over the change in x, or y2 minus y1 divided by x2 minus x1. This is the equation for the slope. The slope-intercept form of a line is y equals mx plus b. Now, I'd also encourage you, where m is the slope and 0b is the y-intercept or vertical intercept. Vertical intercept is the same thing as y-intercept. What I would encourage you to do is stop the video and try these problems, and then you could always come back and watch the video to review. So you want to make sure that this graphing line stuff is pretty obvious to you and sounds very familiar. So before I do the table of values, I'm actually going to rewrite the equation. It's the same equation, 1, 2, and 3, in slope-intercept form, because this is my preference, okay? So in order to do that, I need to get y by itself, because you notice here in slope y-intercept form, y is by itself. If I want to get y by itself here, I'm going to add 2x to both sides. So I get 3y equals 2x plus 12, since that's a positive 12, and I'm adding 2x to it. You can also have 12 plus 2x, it's the same thing. And then to get y by itself, since y is being multiplied by 3, I'm going to divide everything by 3, both sides. So I get y equals 2/3 x plus 4. That means that the slope y-intercept form is y equals 2/3 x plus 4. The slope is 2/3, and the y-intercept or vertical intercept as an ordered pair is 0, 4. That's because if you plug in 0 for x, the only thing left is y equals 4. Now if we graph that using the slope and the y-intercept, we have a y-intercept of 0, 4, and that's right there. And if I go ahead and label it, I would label it with the ordered pair 0, 4. And then to graph the line, I'm going to use the slope. I'm going to rise 2, and you notice right now my scale that's being used here is 2. They're counting by 2 on both axes. We don't have to have the same scale on both axes, but it just so happens that we do. So we're going to go up 2, because remember slope is rise over run. So we go up 2 from 4 to 6, and we're going to run 3. So I have a point here, and then I'm going to go up 2 and rise or run again 3. So I went rise 2, run 3, rise 2, run 3. The -2 over -3, a negative divided by a negative is a positive. So if I go down 2, I can go back 3, down 2, back 3. That means my x-intercept is -6, 0. So I have a y-intercept and I have an x-intercept. Now in order to draw the line, graph the line, I'm just going to connect the dots. And then what I want to do is, with this form of the equation, I can, the slope y-intercept form, I can fill out the table. Now actually I could do, there's a lot of different ways to graph. You can always just plug in numbers, like maybe you want to find the x-intercept and the y-intercept. Well, this would be the y-intercept. When x is 0, all along the x-axis, y is equal to 0. So this would be my x-intercept when y equals 0. And all along the y-axis, x is equal to 0, which is the reason why when we plug in x is 0, I get a y-intercept. So this is using the intercepts to graph. If we use the intercepts, if I plug in x is 0, that's gone. So I would get 3y equals 12 divided by 3, y equals 4. So my y-intercept is 0, 4. And then if I wanted to find the x-intercept, I would set y equal to 0. So if y was equal to 0, I would have negative 2x equals 12, right? Because 0 times 3 is 0. And then I would have the same signs here, so I would have to make sure that I bring that negative down. Negative 2, I would divide both sides by negative 2, and I would get x equals negative 6, negative 6. And you saw that in the previous example that the y-intercept was negative 6. And then if I wanted to find other points, I could use numbers. Because of my slope has a denominator of 3, if I use multiples of 3, negative 3, 3, 6, these are multiples of 3, then that makes it really easy for me to make sure that I'm not going to end up with a fraction point. Because you saw that all of those ordered pair here, negative 3, 2, and 3, 6, and then over here was 6, 8. Those are the same numbers I'm going to get if I plug these values in. But if I plug them in for x, my independent variable, then I would solve for y. So just an example here, if I were to take this as my x value, I'm plugging it in for x, I have 3y minus 2 times negative 3 equals 12. And if I want to solve that, I have 3y plus 6 equals 12. I'm going to minus 6 from both sides. 3y equals 6, and so y equals 2. So we could just go through, I already know what those points are based on this graph down here, but essentially you just be plugging in those x values in order to get the y values. So we know that's going to be 6 and that's going to be 8. And if I plot a third point, so I'll plot this point right here, this ordered pair, negative 3, 2, and you notice that that point will form a line with the other 2 points. They're co-linear. They're on the same line. So that's the exact same line graphed twice, just 2 different ways. Table of values, x and y intercepts, talking about slope y-intercept. This is probably the most popular way of graphing a line. Okay, we'll go on to the next page here. Just reviewing graphing lines. So let's look at this one now. Given the line, state the equation of the line in slope-intercept form. So I already know something about the intercept. The y-intercept is 0, negative 6. That's the ordered pair. If I want to calculate the slope, I would need to look at 2 points and calculate the rise over the run. So here's my x-intercept. The x-intercept, the coordinates are negative 8, 0. I could use the formula that's on the previous page, but because I have the graph here, I might as well just use the graph to help me with my rise and my run. So if I'm going to go down, that's my rise. It's negative 6, because notice it went down negative 2, negative 4, and negative 6. So the rise is negative 6. The run is going in a positive direction from 8 to 0. The run is equal to 8. So let's make that into a fraction. Our slope is rise over run, negative 6 over 8. And of course, we always want to reduce fractions. So that reduces down to, they're both even. Divide them by 2. Half of 6 is negative 3. Half of 8 is 4. So our slope is 3/4, negative 3/4. And you could have seen I could have gone down negative 3 over 4, and I would end up, on another point on the graph. Okay, so we put it together. The equation of the line, y equals negative 3/4 times x, because that's the slope times x, minus 6. All the time when your line is going down, it's decreasing from left to right, that's always going to have a negative slope. Whereas the previous example has a positive slope because the line is going up from left to right. Okay, so now if we want to find the equation of the line that passes through the following points, and actually I'll just do this on the next video.